Welcome to the first episode of Unit 2, Linear Relations. So Unit 2 consists of 3 chapters in your textbook, chapters 3, 4, and 5. And we are going to start slope as a rate of change. Pretty simple concepts that you have covered already. All right, so we begin as usual with our Minds On. So if you have not completed your Minds On for lesson 3.1, please go ahead and do that now. Pause the video and complete that. Okay, here is the Minds On. So we've got over here a Cartesian plane, we call that, or a coordinate plane, or sometimes we call it a planal graph. And up here, what we have is we've got ordered pairs. These can be referred to as points. Sometimes they're called coordinate pairs. Each one of these is a coordinate. So it's important that we think of them as ordered pairs because they have an order, an alphabetical order, X, then Y, right? So that really is very helpful to know when you're going ahead and plotting these. So we always go to the origin, which is the intersection of the x-axis. This is the horizontal axis, is the x, and the vertical axis, which is called the y-axis. So the origin is the intersection of those two, and we are going to start by going left 2 units if we're plotting that first point, negative 2, 3, because the x is negative. So negative 2 is left, and then up is positive 3. So we go up 3 from there. Okay, so I'm going to plot the point negative 2, 3. 4, 0, go back to the origin, and we're going right this time. 1, 2, 3, 4, and we don't go up or down at all because our y value is 0. So this is 4, 0. Go back to the origin, positive 1, right 1, and then down 3. 1, 2, 3. Okay, so just make sure you're going x axis and then y. 3, 4, so again positive 3 is 1, 2, 3, and positive 4 is 1, 2, 3, 4. Pen doesn't cooperate sometimes. That's the point 3, 4. And last but not least, negative 4, negative 2, so left 4 and down 2. So have a look at your Minds On and make sure that you plotted all of those correctly. If you're having difficulty with plotting points, just pause the video right now and ask me any questions that you have. Okay, in the meantime, we're going to move on then and start the lesson. So you should have your note in front of you, and please try and follow along. Copy the examples. When I ask you to do the practice question, pause the video, do the practice, and then I will come back on and show you the answer, and that way you know whether you're getting, you're understanding that particular concept. If you're not, if you, for instance, do the try here and are having difficulty with it, then please pause the video and come and ask me for some help at this point, okay? All right, so let's get started. Slope is a rate of change. So today's learning goals, we've got 3 of them. We're going to create a table of values from an equation. Been there, done that, right guys? You've done that before. You're going to graph a line from a table of values, easy. And you're going to determine the slope of a line from a graph. And you're going to determine the rate of change from a table of values. Not so difficult either, okay? And those are concepts that you have seen before. Okay, so slope. Slope is just a number that measures the steepness of a line. So if you have a big number, like 10, that slope is actually, that line is pretty steep. If you had a slope of like 1 over 5, that slope is pretty not steep or flat. And we measure the slope of a line by counting on a graph the rise compared to the run. So we get this ratio or fraction that represents the numeric value of the slope. All right, so for slope, you always need 2 points on your line. And it doesn't matter which 2 points you pick, your slope's going to be the same. you're going to find two exact points. And what this means is that you're going to go to your line and you're going to pick 2 points that are at the intersection of a grid line. You see how this point here was chosen very specifically because it intersected the grid line, and we could see, oh, if we go back and try and identify the coordinates of that point, it's easy. We go over 1 full square and then we go up 4, so the coordinates of this point are 1, 4. Had I picked a point, let me just make this pen if I can. Doesn't. Oh, sorry, red. If I picked, say, this point on this line, well, it's very difficult to figure out what the coordinates of that point are. It's not quite 1. Is it a half? Is it 2/3? Not sure. And it's a little more than 3, but it's less than 4. What is it? 3.2, 3.5, 3 1/3. So you're always going to go to where the grid lines intersect to pick up your points for a line. All right. So what it says here is to determine the slope, you find 2 exact points, you draw a right triangle, you count the rise, you count the run, and then you decide if it's positive or negative. So let's see if we can make this happen. So I'm just going to get rid of that dot. All right, so let's pick 2 points. Why don't I pick this one and this one? So C and D. Well, it says here actually find the slope of A and B and C and A and D. So let's start in order. So if I'm looking to find the slope of AB, oh, I can see that my graph has been cut off. So what I'm going to do is I could just say this is A here then. So if I find the slope of AB, this is the line segment AB, the letters seem to be just slightly off. Then what I'm going to do is I'm going to draw a right triangle. So what I do here is I start at one of my points. It doesn't really matter which one I do. And I'm going to draw a right triangle by going up to the height of the other dot that I'm trying to get to. And then I'm going to go across. So really what I did, I'm just going to put an arrow there. I went up and I went this way. Okay? So now what I want to do to figure out the slope, I know the slope is rise over run, right? And so I have to count my rise. So this is my rise, obviously. How far did I go up? Each square is worth 1 unit, as I can see on my scale. So I'm just going to count 1, 2. My rise was 2. My run was 1. I only had to go over 1 square. So my slope is 2 over 1, and you would simplify that down to 2. 2 over 1 is just 2. So let's see what BC does. If I'm going from here, which is B, to C, then I am going to, again, I could start with this one this time, and I could go down to the level of my point, and then this way. So I went down, which is, there's my arrow. It's hard to write with this pen, so it's a little bit messy. And there I'm going left, as you can see. So this time I went from here, I went down 2 and left 1. Well, down is negative. So I went down 2 and then I went left 1. And you can see that left, remember when we were plotting our points, left is negative. So this would be negative 2 over negative 1. But negative 2 over negative 1, a negative over negative, is a positive. So this is also just 2. If we continue on the same way, drawing our right triangles, so if I wanted to find CD, and, sorry, that was BC. Now I'm going to do AD. So if I wanted to do AD, I'm just going to change colors here. I'll use, oopsie, sorry. Do I have a green pen chosen? I can't tell. There we go. So if I wanted to find the slope of AD, I'm going to go all the way from A all the way up to D. So again, I'll start with one of them, and then I'm just going to mosey on up to the height of my D. And then I'm going to, so that was going up, and then I'm going this way to get to my other point. So that was that direction. So I've drawn my right triangle, right? This is like the hypotenuse here. And I'm just going to count again. 1, 2, 3, 4, 5, 6 units up. So positive 6 over 1, 2, 3 units. Right. So 6 over 3 is 2 as well. I'm running out of room here. And then the slope of BD is going to be, let's see, from B to D is from here to D. So let's just choose another color here. And what I'm going to do is go from down again instead. Go from D to B because it really doesn't matter. So this one's B. So I'm going to go down, so hard, to the level of B, which is here, and then over. So down, I'm marking the arrow, the direction that I was going. So I have to start with my rise always. So I was not rising, I was actually lowering, right? So 1, 2, 3, 4. So that's going to be -4. And then from here, because now I'm down here, I'm going left 2, 1, 2. And so that's going to end up being -2 when I go left. So -4 over -2, which is just 2. So it should not surprise you that the slope of every one of these was the same. It was the same steepness. The slope of every one of these segments was 2, and therefore the slope of the line segment is also 2. So its slope doesn't have any units, it's just a number. Okay, so here's where I want you to pause the video and do the try. So the try is the same question. Determine the slope of the line shown. So you have to pick 2 points. You get to pick any points along the line. A line is made up of an infinite number of points, but be smart. Pick the ones that intersect the grid lines. Okay, good luck, and come on back when you're finished. Okay, so let's see how you did. Let's pick 2 points on this line. So I'm going to pick this one. To me, that's kind of obvious. That's an excellent point to choose because it crosses at a grid line. And I can see that if I go along here, that's not a good point to pick because it's not at an intersection. This one's not good, but this one's good. This is the origin. So I'm going to draw my right triangle. So I go to either point. It doesn't matter, but I got to get to the other one. So how do I get to the other one? I'm going to do rise first. So I'm going to go down first. So always do rise first and then run. So, and there's my run, right? So I went from here and I went down. And then I went right. So how many squares did I go down? I went down 1 square. So the rise is going to be -1. And the run is going to be 1, 2, 3. -1/3 is my slope. So this line is sloping negatively. As you can see, it's the opposite of this one that's sloping positively. Always reduce your fractions. So sometimes you'll get something like -2/6, and you would reduce it down to its simplest form. Okay, so now we're going to calculate rates of change. And what we're going to do first is we're going to create a table of values for an equation. We're given the equation y equals 3x plus 4 here. We're going to presume that our x values are 0, 1, 2, 3, and 4. But remember, for a line, the x values can be anything, but we're just using the easy ones, and we're just going up by ones. And it's important that we go up by a constant amount. So up by ones is the easiest. And then we're going to determine the rate of change in the y's by just subtracting the y values. Okay, so let's just write down our x values. So we've got, 0, 1, 2, 3, 4. And then we have to figure out what y is when x is 0. So over here we can just do our calculations. You might be able to do them in your head. 3 times 0 plus 4. Well, I know that 3 times 0 plus 4 this is 0, and then we're left with 4. So there's the first one. The second one would be y equals 3 times x, which in this case now is 1 plus 4. So y equals 3 plus 4, y equals 7. And we're going to keep going like that. So y equals 3 times 2 plus 4, 6 plus 4 is 10. 3 times 3 is 9 plus 4 is 13. And 3 times 4 is 12. 12 plus 4 is 16. Okay, so I'm doing it in my head, but you can certainly write it down and calculate it for each one of them. Okay, and so now what we're going to do is we're going to figure out what the rate of change of the y's is. And we do that by taking the second one minus the first one. So the bottom minus the one on the top. So 7 minus 4, 3. Then we go down to the third one. The third one minus the second one. 10 minus 7, 3. 13 minus 10, 3. 16 minus 13, 3. So we can say now that the rate of change is 3, and therefore the slope is 3, because the rate of change and the slope are the same concepts. Okay? So the slope of y equals 3x plus 4 is 3. So I want you to go ahead and try this one. Just pause the video right now and do the try. Okay. So hopefully you were able to determine the y values given your equation. Your equation was slightly different because the x was after the constant, but really no big deal. Just substitute in the x. So when x is 0, y equals 2 minus 0, which is 2. When x is 1, y is 2 minus 1, which is 1. When x is 2, y is 2 minus 2, which is 0. When x is 3, now you've got a number bigger here that you're subtracting away from the 2, so that's negative 1 and negative 2. 2 minus 4. And then again, we start with the second one minus the first one. So 1 minus 2 is negative 1. 0 minus 1 is negative 1. Negative 1 minus 0 is negative 1. And this is tricky, but minus 2 minus minus 1 is like saying minus 2 plus 1. So minus 2 plus 1 is also minus 1. And I know I've done that in my head, but you can certainly, if you need to find the differences, do something like this. You can say the differences, you can use a symbol like this, the change in the y's is equal to negative 2 minus negative 1, which is negative 2 plus 1, which is negative 1. So if you need to do something like that, or you can write it like this, the change in the y. You can do something like that if you like. Okay, so there's the table of values, and we can see that the first differences are all negative 1, and so that is the slope of this particular line. And that is, I believe, oh, no, sorry, I lied. All right, here's a real life example. Carrie is selling t-shirts, and we've got a table of values that shows her earnings depending on the number of t-shirts that she sells. So if she sells no t-shirts, she makes no money. That's not surprising. If she sells one t-shirt, she makes $5. 2 t-shirts, $10, 3 t-shirts, $15, 4 t-shirts, $20. So it says determine the rate of change in Carrie's earnings. So remember, it's the rate of change in the y's. In this case, the y's are the earnings and the t-shirts are like the x's, because the independent variable is the x. It's the thing that you really can't control. She sells 0, 1, 2, 3, 4, but what she does control is her earnings. So her earnings are dependent on the number of t-shirts that she sells. Okay, so determine the rate of change in Carrie's earnings. So we would look at that, and I don't have it the same way now. I've got to kind of do a change this way. So 5 minus 0 is 5. 10 minus 5 is also 5. 15 minus 10 is 5. 20 minus 15 is 5. And we can see then that the rate of change is $5 for every t-shirt sold. So for every one t-shirt that she sells, she gets an additional $5. So it says graph the data from the table and then determine the slope of the line. So 1, 2, 3, 4, and then 0. Okay, so 0, 0. Just trying to memorize it here. Got the point 0, 0. Got the point 1, 5. Now my scale is kind of funny because this is 6, so I'll go halfway between 4 and 6. So 1, 5, 2, 10, 3, 15, so 12, 14, 15, about there, and 4, 20, 16, 18. So you can see this forms a line. Now I'm going to have some difficulty graphing the line. Let me see if I can use my, oh, that's much better. And maybe I'll just put an arrow on the end of it too, because if she sells more t-shirts, she's going to earn more money. So this is t-shirts. Oopsie. Let's just see. Let's go ahead and do that. Is that better? Yeah. So now we can see that I should be putting on here the number of t-shirts sold. I have a feeling that it's not going to let me. Yeah, it's moving things around, which means I should try to lock this. See if I can do that. Okay, so let's see. Number, go back to my pen, number of t-shirts sold. That's on my x-axis. On my y's is my earnings or her earnings. And the units in this case are dollars. Okay, and then you might want to put a little title up here. Can't remember her name. So, oh goodness. Carrie's t-shirt sales. So Carrie's t-shirt sales, and we're going to label 2 points. So 0, 0 is one of the points. She sells no t-shirts, she makes no money. And we can also say 1, 5. She sells one t-shirt, she makes $5. What is the slope of this line? Well, we could try and use our method that we learned, which was basically go from one point to another, draw a right triangle. So I might just go from this point. Let's go up to this one here. So up and over. Now this is tricky because before we just counted the number of squares, but you can see that each of the squares is worth 2, so we have to skip count this time. 2, 4, 6, 8, 10, so I went up 10, and each of the squares over on the x-axis is worth 1, so I'm just going to count 1, 2. Alright, so that was tricky. So it was 10 up and over 2, both positive. So the slope is 10 over 2, and the slope is then 5, and it's the same as the rate of change. So we could do it from a table of values as we did at the very beginning. We found the slope, or we called it the rate of change, same thing. Or we could find the slope of the line using our little method of calculating or drawing the right triangle and counting the squares. Okay, so rise is this overrun, slope is the same as rate of change. All right, guys, that's it. Can you please do your consolidate and put it on my desk? And if you have any questions, come and see me now. Otherwise, start on your homework, please. It's on your unit outline. I'm not going to write it down for you. So just, you have your unit outline. You're going to go to the 3.1, because this is the note 3.1. Slope is a rate of change. Look on your unit outline and do that homework. All right, thanks a lot. Bye-bye.